Hello friends, how are you? I hope you all are well. Today in this video I am going to explain one important laws, that is KIRCHHOFF'S laws. There are two laws are there. One is Junction law. It is also we say KCL, KIRCHHOFF'S current law. Second one is the loop law. This is KIRCHHOFF'S second law. We say also KVL, KIRCHHOFF'S voltage law. So at first I am going to explain Junction law or KCL, KIRCHHOFF'S current law. What is that law? The sum of all the currents directed towards a point is equal to sum of all the currents directed away from the point. I have written here the sum of all the current directed towards a point is equal to sum of all the currents directed away from the point. That means, for example, say that this is the current I1, this is the current I2, this is the current I3, this is the current I4. Listen carefully. I have written here junction law. What do you mean by junction? The KIRCHHOFF'S first law is also called junction law. The thing is that here is a junction. Junction in the sense the point where three or more wires meet, join. That point is called a junction. That's why it is also called junction law. KIRCHHOFF'S first law is also called junction law, or we say KIRCHHOFF'S current law. Here you observe that I1 and I2 is the amount of current entering to this point. At the same time, I3 and I4 are the amount of currents leaving this point. So I can say that I1 plus I2 is equal to I3 plus I4. That means the amount of current entering into the junction is also equal to amount of current leaving the junction. For example, if I take the current towards the point I1 and I2 as positive and the currents I3 and I4, those are away from the points, are negative, then I can write that I1 plus I2 minus I3 means plus minus I3 minus I4 is equal to 0. So now the same law can be restated as the amount of currents, or I can say that the algebraic sum of the current towards a point is 0. I can say that the algebraic sum of the currents towards a point is 0. That means I can say that the net current at this point is 0. How much current is entering here? At the same time, the same amount of current leaving the point. So I can say that at a point, there is no point which can keep some accumulating charge. I can say that there is no point in a circuit, no point in a circuit which can or which keeps on accumulating charges. There is no point in a circuit which keeps on accumulating charges and keeps on supplying charges. That means at any particular point, continuously it can't gather the charges and it can't supply the charges. Just charges pass through the point. Just charges passes through point. That means how much charge entering here, at the same time same charge also leaving that. So I have said that there is no point in a circuit which keeps on accumulating charges and keeps on supplying charges. Just charges pass through that point. So this is all about Junction law, which is Kirchhoff's first law. We also say it Kirchhoff's current law. The second law. So children, if the video you like, you can like it. At the same time, don't forget to comment and subscribe. As a result, you can get the information about our upcoming videos regularly, which can help you in your study. So let us see the second law, Kirchhoff's second law. This is also called loop law. It is also, we say, KVL, Kirchhoff's voltage law. So you see that according to this law, the sum of all the potential differences along a loop in a closed circuit is 0. Listen carefully. For example, here is a simple circuit is there. Is the cell. This is the resistor. For example, this is simple circuit. So this is negative end, this is positive end. Whenever current flow through the circuit, some places there will be rise in potential difference, some places there will be drop in potential differences. But the sum of all the potential difference along a loop closed circuit is all the time 0. Now let us see, for example, here potential difference is 10 volt. Here the resistance is 1 ohm. Now at this point, here is potential difference 10 volt. Potential difference 10 volt in the sense the difference between these two ends is 10 volt. That means, for example, here is 10 volt. That means it may be 0. The differences is 10. I am not saying this is 0, this is 10. It may be 10, it may be 20. 20 and 10 difference is 10. So the potential differences, I am not telling about the electromotive force. I am saying about the potential differences. So here the potential difference is suppose 10 volt. Here the resistance I have mentioned 1 ohm. For example, the current is flowing in the circuit is I ampere. Current is I ampere. In this case, if I use the KIRCHHOFF'S loop law, whenever we apply the loop law, we have to start from a point and we have to move along this loop and again we have to reach at the same point. But how we move does not matter. We may move clockwise, we may move anti-clockwise, does not matter. But the point from where we are starting, again we have to come back to this same point. Then the loop will be closed, or the circuit is closed, I can say. So I have written some of all the potential difference along a loop. Here the potential difference is 10 volt. So one point you remember, when the potential difference rise, we take it as positive. When potential difference drops, we take as negative. So potential difference increase, we take it as positive. Potential difference drops, means decrease, we take as negative. This sign convention is very important for you. So suppose I am moving from this point A, this is B, this is C, this is D. So here is the potential difference is 10 volt. So I am writing this is 10 volt. Again I am moving from B to C. So whenever I am moving from B to C, there is a resistor. So definitely there will be a potential drop. So in this case, I shall use the potential difference as minus I into 1. This total is equal to 0. Listen carefully. I have written that 10 volt as positive because here potential difference rises, increases. I am going from this side to this side. It increases. Here is 10. Difference is 10. So that you can consider this is at 0. I am not telling this is 0. Suppose this is 10, it may be 20. This is 15, it may be 25. But the difference is 10 volt, means here potential rise. Here potential drops. So I can say that here is the 10 volt. Here is the volt potential difference is the, according to Ohm's law, V equal to IR. If the current is I, if the resistance is R, then I can say that this is minus I into 1 is equal to 0. If I want to calculate the current, then I can say that I shall not use this one. I will use I is equal to 10 ampere. Okay. So now we'll see somewhat more complex. Now you see. So the second law is called loop law because it's based on the loop. See here. Now we'll make little complex. This is the first case I took. Suppose in this case one more cell will connect it. This is the resistor. Okay. Now you see that. Suppose we start from this point A. I've written here B, C, D, E, F, like that. Here there are two loops are there. One circuit is A, B, E, F. Another one you can consider B, C, D, E, or this total also we can consider as a loop. Okay. Suppose in this case the amount of current flowing is I ampere. So according to junction law, the amount of current entering into the junction is also equal to amount of current leaving the junction. That means the current I ampere came here. Thereafter it divided into here I1, here I2. Suppose this is I1, this is I2. For example, the current is going like this way and like this way. For example, I am not telling it is correct. Correct or wrong, we can find. How we find, I shall say. So there may be chance here. I have taken, let the current is going like this way. Let the current is going like this way. So here I have taken I1. Here I have taken I2. For example, this is 5 volt. This is 2 volt. Here is 1 ohm. Here is also 1 ohm. These resistors are there. Now we consider the loop A, B, E, F, A. A, B, E, F, A. Okay. Now you see that this I ampere current divided into I1 and I2. So I can say that I is equal to I1 plus I2. Now we consider the loop A, B, E, F, A. In this loop, suppose I decided to move like this way. If I move like this way, whenever I reach here, this is rise in potential difference. So I can take this is the 5. Potential difference is 5. There is a rise in potential difference. That's why I have taken it positive. But whenever it is going through this resistor, definitely there is a potential drop because there is a resistor. So I shall take here potential difference through this resistor is negative. So now I shall write current is I2, resistance is 1. That means minus I2 into 1. This is equal to 0, or I can say that I2 current is equal to 5 ampere. So I got the current I2 is equal to 5 ampere. Actually, my aim is to calculate the current I. I shall consider one more loop. Suppose consider the loop B, C, D, E, B. Now, I am moving from here. I am moving from small to big one, means negative to positive. This is the negative, positive, this is negative, this is positive. So here there is a rise in potential difference. Definitely I shall write this is the 2. This is plus 2. Again, the current I1 is here. We have taken that this is the I1. So the potential difference through these resistors is equal to IR. I is here I1, R is 1. That means minus I1 into 1. Since you know that Ohm's law V equal to IR. Okay. Again I came like this way. Again I am moving like this way. So whenever I am moving, this current is here I2, resistance is 1. I shall take the positive. Yes, I shall take it positive because that time when I moved here, I took it as negative. So whenever I am going in opposite direction, that means I have to take it as positive. That's why I am writing this positive. This is equal to 0 or 2 minus I1 plus I2 is equal to 0. Here I have got already I2 is equal to 5 ampere. Implies that 2 minus I1 plus 5 is equal to 0. Implies that minus I1 is equal to 2 plus 5, 7. That's it, minus 7. Implies that I1 is equal to 7 ampere. See here, once again I am repeating. I am moving from B to C, C to D, D to E, again E to B. Whenever I am moving from here to here, there is a potential rise. You are moving from negative side to positive side. So I have taken that is positive. But whenever I am moving like this, there is a potential drop. That's why I have taken it is negative. But again when I am moving here, I am going against the potential drop. Previous time I have taken this is the potential drop downwards. Now I am going upwards. That's why I have used the plus symbol, that is I2 into 1. That means potential difference is equal to I2. So in this equation I have taken the value of I2 is equal to 5 ampere. I got I1 is equal to 7 ampere. See that here I got the result positive. Here I have taken the result also got the positive. That means my thinking that this is the direction of current is absolutely correct. So suppose this answer were minus 7 or minus 5. That means the direction what I have taken, that is wrong. So easily we can find its direction without confusion, but we have to find the current. If it is negative answer came negative, that means the direction what we decided, that is reverse. If the answer is positive, the direction what we thought, that is exactly correct. So this is about KIRCHHOFF'S two laws. One is the loop law, second First one is the junction law, that is called the KCL. Second one is the loop law, that is KVL. I hope that you understood it. So in the next video, I shall explain some more numerical problems based on Kirchhoff's law. Until then, bye.